In this lesson, we will be discussing C structures. Structures allow you to create custom data types by grouping related variables under a single name. It allows you to group related variables of different types. This allows you to create custom data types for your programs. You can access members using dot notation. Structures allow you to pass entire data collections as a single unit. Here's an example of a basic structure definition. This code defines a structure named student, which contains a character array for the student's name with a length of 50 characters, an integer for the student's roll number, and a float for the student's marks. Now let's explore how to declare and initialize structures. Here's how to declare structure variables. The code defines a structure called person, which contains a character array for the person's name with a length of 50 characters, an integer for the person's age, and a float for the person's height. The code declares two structure variables named person1 and person2, both of type person. Remember that each structure variable contains its own copy of all member variables. Now let's look at how to initialize structure variables. The first method is member by member. In this method, we specify each of the members of the structure one at a time. We assign the age of person1 to 25, the height of person1 to 175.5, and the name of person1 to John, using the string copy function. The second method is to declare at the time of definition. This is where we define all the members inside curly braces, separated by commas. We define the person3 variable of type person, and initialize name to Alice, age to 30, and height to 165.0. In this section, we'll learn how to access structure members. Here's how to use the dot operator. This code defines a structure named book, which contains a character array for the book's title with a length of 100 characters, a character array for the book's author with a length of 50 characters, and a float for the book's price. Inside the main function, a structure variable named myBook of typebook is initialized with the title C Programming, the author Dennis Ritchie, and the price $29.99. Accessing structure members is demonstrated using the printf function to print the title, author, and price of the book using dot notation to access each member. The dot operator is used to access individual members of a structure variable. It connects the structure variable name with the member name. Each member can be treated as a normal variable of its declared type once accessed. You can read from it or write to it as needed. Now let's explore nested structures. A nested structure is nothing but a structure within a structure. This code defines a structure named address, which contains character arrays for the street with a length of 50 characters, the city with a length of 30 characters, the state with a length of 20 characters, and an integer for the zip code. Then it defines another structure named employee, which contains a character array for the name with a length of 50 characters, an integer for the ID, and a nested structure of type address named office address. Use multiple dot operators to access members of nested structures. The example shows how to access the city member of the office address structure within the employee1 structure. Benefits of using nested structures is that it organizes related data hierarchically, creating more complex data structures. It improves code readability and organization, allowing logical grouping of information. Let's learn about arrays of structures. This code defines a structure named student, which contains a character array for the student's name with a length of 50 characters, an integer for the roll number, and a float for the marks. An array of structures named class is declared, which can hold 5 student records. Accessing array elements is demonstrated by assigning the roll number 101 and the marks 85.5 to the first element of the class array, which is class at index 0. The access pattern is array name, followed by the index number in square brackets, followed by the dot operator, followed by the member name. They are perfect for storing collections of similar objects like student records, inventory items, or employee data. Now let's see how structures and functions work together. This code defines a structure named rectangle, which contains a float for the length and a float for the width. A function named calculate area is defined, which takes a structure of type rectangle as a parameter and returns the area of the rectangle, which is calculated by multiplying the length and width members of the rectangle structure. Structures are passed by value by default, creating a copy of the entire structure. Now let's look at how to return structures from functions. This code defines a function named createRectangle, which takes two floats, L and W, as parameters and returns a structure of type rectangle. Inside the function, a structure variable named rect of type rectangle is declared. The length and width members of the rect structure are assigned the values of L and W, respectively. Finally, the rect structure is returned. The code demonstrates how to use the createRectangle function to create a rectangle with a length of 5.0 and a width of 3.0, and assigns it to a structure variable named myRect of type rectangle. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.